So in another video, intro video, I showed you just some basic things about Praxis for Slack and how it's designed and what some of the decisions were in that area, and a little bit about the programming language and things like that. And in this one, I want to focus more on showing you how about the programming environment, a little more about the programming environment, and really how powerful it is, and how easy it is to write Slack bots or Slack components or smart contracts. They're all done with the same language and using the same tool. So basically in Praxis code here in our web app, everything that's connected when you connect through Praxis code, there's a two-way communication between our Slack bot and the web app. So yeah, it's very efficient communication. So we take full advantage of it to give you basically live debugging of Slack interactions and Slack bots and all the things that you do on Slack. So we give you some examples of that here. This happens to be a template that I'm writing that will be one of our examples. It's called incentive sign off, and this is something that will eventually, when someone drops a file into the channel, if the file has a certain pattern, it will kick off a sign-off process. And part of the development of this that we'll do will be the way it'll work is you'll be able to associate a file pattern to a list of Slack users, and they'll get messages, and then they'll be able to sign off on the file using, in this case, we'd use a smart contract to do that, so everything would be recorded on a blockchain. That's just a side note. So these are called templates. That's the term that we use for basically a component might be another term, or it's like kind of like a class, I guess, in some languages. And I'll just go to our starter template, and this language, the programming language we use is called JSONata, and it's a small language, but it's fully functional. It's a functional language, and it's it's very rich. You can do anything with it. It's kind of JavaScript-like, I guess, in some ways, but yeah, there's really it's a full complete language, and it's normally used, or the way it's advertised is for JSON transformations, and that's the model that we use. So that's that's the programming language that we chose to write our smart contracts with, and it's also used for, it's the same thing, it's used for Slack components or bots. The difference is that when you instantiate the JSONata in our code, you can customize it. So we can add a lot of customized functions, and in this case, we have a huge set of the Slack API built into the JSONata that runs inside our Slack bot. So you can really, there's really no limitations on what you can do inside one of these methods. So this I have a video that explains what this method does. This is a method that displays a modal, and this is another method that we have that shows you how to set up a Slack button interaction. And this is one that we distribute also. This is something that you would do. You would actually, this is something you would do with Praxis for Slack. It's creating a user interface to start a smart contract that will do sending of coins to a specific user. So that this is something, this is a smart contract you might use quite a bit, because you might want to set something up to track sending things to a specific person. So that's what this does, but it just gives you a good example of the whole point of what we're trying to do with Praxis for Slack. It's basically we're using Slack as our user interface for the product, for not only our smart contracts, but for, as I said, it's very general, so you can use it for Slack components and other things as well. But yeah, it's just leveraging Slack to do all to interact with the user, and then to take that information and do whatever you want with it. In the last year, Slack's come a long way, and they keep adding things to their API, so that it's getting more sophisticated. You can write fairly good user interfaces now with Slack. They have modals, and they have other things called interactions, which are buttons and drop downs. You see some of the things here. So that's what we did, and probably the coolest thing from a coder point of view is everything is live. So if I look here and interact, you can see we have a breakpoint. It's actually a function, and you just put this wherever you want in your code, and when you start this method, there's a lot of ways to do that. The easiest way to do it on the Slack side is we have a command that you can start at. You can start a random method, but it's also possible to attach methods to buttons and things like that. So that's something you would do when you're writing something more sophisticated. But when a breakpoint's hit, it will show you all the data that's in your method that you're using. That the programming model that we have, it's a lot like React Redux, if you're familiar with that. It's basically actions and reducers, and sometimes reducers will be called methods or effects. So that's the way it works. You make an action that contains a reducer, and it gets the state, and it modifies the state and creates a new state. So that's the programming model, and everything is JSON on the programming side. So, but yeah, the live debugging is definitely the most valuable thing. I'll show you some of that in a second. I just want to go through a couple things first. So a couple other things. So here's some of our start contracts, and this is the send. What I said something about it before. It's a smart contract that you give it a ledger, and then when you send something through this smart contract, it will just send it to that ledger, and also it does tracking and things like that. So it's more than just sending. And this other smart contract is called Ask, and it's similar to there's a crypto business that I think Coinbase bought it some time ago, but it was called Earn, and what it did was you would send some Bitcoin, or maybe it accepted other crypto too, but you might send $20 in Bitcoin and an email to someone who was subscribed to Earn, and it was usually somebody who was in high demand, an influencer, or somebody in the crypto space that you wanted to get a reply from. And normally, if you just cold email people, you're not going to get a reply. But if you send them, $20 in Bitcoin, you'll probably get a reply. Maybe not $20, maybe more, maybe less. It depends on who the person is. So that's what this ask contract does. You can start an ask contract yourself, and then somebody can send you some. In this case, it would be Prax, which is our coin, and that would send them a Slack message, and the Slack message would say that whoever you are sent 20 Prax, and they want to know something. And so more than likely, the way this smart contract works is there's no like verification, or there's no demand, or there's no backtracking. So normally the person will be willing to reply to you if you send them an incentive, basically. So that's what a couple of the samples are. And so I'll go back to starter here, and I'll just this is running another video, but I'll just show you how slick it is, and how everything is done live. So if I go back to here, I have a shortcut that will start this. It's a very sophisticated and powerful command language that we have. So if I start this, it's just two kind of random fields that I'm putting on this modal right now. But right now the code is sitting right here on this reply modal, and I'll just push cancel, and you can see that it hits this breakpoint, which is the then statement for. I didn't actually do a submission. So when you come over to the data, there's a lot of stuff in here. It's a lot of the variables that you have on the left hand side, but it also has, if we go down a little bit further, it will have a lot of the Slack information. You can see that, you can find that down here. This is the state that we started with, and here's the action that came in, interact, and it has a bunch of things in there that you don't really have to know too much about right now, but it has a context, and you can see it just has information about the user ID and the team and the channel that it came in on. So you can use that information to reply and for various other things. But the live debugging is the really important part of this. So if I continue, it just ends, and that's the method ends. So let me go to, I'll just show a button. This one was shown too in another video. Interact button. So I have a shortcut for this also. Test BUT. So it displays a message with the button in it. And let's see now if I click the button, we can see the breakpoint gets hit in the button handler. So I'll just terminate this one. So yeah, that's some important things. One thing I forgot to show you in here is start contracts. So these are actual contracts. Some of these they're not smart contracts. They're things that are running inside Slack or to build UIs. And the smart contracts, these will actually run on the blockchain. There's no difference in the programming language, but there is in the functions that you get and a lot of things that you can do. It's more restricted here. But one of the cool, nice things is, since it does run in two different environments, you can write a test, you can write your tests for your smart contracts, and we already have a kind of a mock environment, which is running inside the Slack bot. It's a superset of the smart contract language, and it doesn't really record anything on the blockchain. So you can actually write tests. You can test your entire smart contract before you deploy it or use it. So that's what this does. It's this is what the run effect is. What will run it'll run a method from a template. It doesn't matter if the template is a smart contract or not. In this case, they are smart contracts. So I'm running the smart contracts, and then I'm looking at the state that the smart contract is creating, and I'm doing a search and just the normal kinds of things that you would do with tests. And in this one, I'm even inside my test. I'm actually displaying a modal to the user to select an output, and then using that and further down in the tests. So it's very sophisticated and very handy to have that facility built in. So you could write a full test suite for your smart contracts long before you even have to deploy them or even try to use them. And on the Slack side, I'm going to expand this just a little bit. We're taking advantage of the app home that Slack. It's a new feature in Slack that you can have something called app home, and whenever a user clicks this home, we get notified, and we can build basically a page for them to do various things. And so we allow you to do a number of things that you can use Praxis for right from the home page, mostly related to ledgers. One thing that I should note about our smart contract language is that everything that a smart contract generates is called an output, and those are what appears in your ledgers. And outputs normally will have coins in them or other tokenized assets that look like everything looks like a coin, but you can have multiple coins and multiple assets in outputs. But outputs are a fairly general concept, and they can be used just really as placeholders for future interactions with smart contracts. For example, you might have a smart contract that needs to get a payment, and so what you would do is you would send the person who signed up, they would get an output that's basically a bill that says, pay this by a certain date, and inside that output it can have all the data necessary for them, so they don't have to do anything except attach a payment. They would basically create an output with the coins or the money or the payment, and send the payment back with the bill or the invoice that's what you could refer to it as, I guess. And then it would automatically do everything for them, and the person it makes it very streamlined and easy from the point of view of everybody interacting with whatever that smart contract is. So that's why you see this output prax. You can if you wanted to send somebody 100 pracs, you have to create an output with 100 pracs in it first, and then you send it to them. There's a lot of advantages to having an output-based smart contract language versus an account-based one. And one of the big advantages, I think, is safety. You can't ever lose more than you send to a smart contract. So if you create an output for 10 pracs and you send it to a smart contract and it turns out it's fraudulent or whatever, you can only lose that 10 pracs because it's really an independent entity, and there's no way they can gain access to anything else. So that's one of the nice features of that. But yeah, if we look on the homepage, there's lots of we we have a very good command language, and a big thing is the shortcuts. You can program shortcuts here as well. There's a create shortcut function, so that's something you might do if you're making a fairly extensive component. You might want to have a lot of shortcuts, and I won't go into too much detail. There'll be another video for doing this, but you can. This is the syntax of creating a shortcut, and these are just like we're just turning this send into this string. But there's also a very sophisticated substitution language that you can use so that you can have multiple word shortcuts and things like that. So you could make things very pleasing to the user. So I don't know if I want to say much more. Yeah, I really just wanted to emphasize the live debugging, because you really can sit down and in one session, like I said, it has the ability to write these tests for smart contracts, and you can test anything, not just the smart contract methods, but any of the methods. But you can really sit down in one session and do the whole thing. It's possible to do that, to really do really big things very very quickly, because you're not running in a simulated environment. You're kind of running live, and so you get immediate feedback. Yeah, so be sure to watch some of the other videos that have more specific information. And thanks for watching this one.